Hello everyone, and thank you for joining us today for our HashiCorp webinar, where today we'll be discussing advanced data protection for banking and financial services. My name is Connor Beechnall, Senior Field Marketing Manager here at HashiCorp, and I'll be your moderator for today's session. And I'm joined by Russ Parslow, Staff Solutions Engineer, who'll be your presenter today. In terms of the agenda, Russ will start with a presentation before getting into a demo, and after around 45 minutes, we'll wrap up for a live Q&A session. If you do have any questions throughout the presentation, please post those in the Q&A box provided, and we'll answer those at the end. Lastly, please note that this webinar is being recorded and will send out to everyone by email after it's been processed, usually within a day or two. So with that, over to you, Russ.
Awesome. Thank you so much, Connor. Welcome everyone today to today's webinar on Vault and advanced data protection. So let's get started. The obligatory introduction slide. My name is Russ Parslow, as Connor said. I work in the solutions engineering team in London, in the UK. I've been with HashiCorp now for, gosh, about 2.5 years. So it feels like quite a long time. A lot of that time are actually spent working with customers, with Vault in particular, and also in the financial sector as well. So we have a lot of customers in the financial sector. Perhaps some of you have joined us today. So today's topic is going to be a more sort of advanced topic about Vault today. So we are going to do a little bit of an introduction to Vault if some people aren't super familiar with it and what it is and kind of how it works. But then we're going to start talking about some of the challenges around data protection. How is it that we protect our data? Why is it sometimes difficult to protect our data? And then also how Vault can help us solve some of those challenges. As Connor mentioned, we'll also do a demo after the presentation. It will be a live demo, so fingers crossed. I'm sure it will all go absolutely fine. And I'll talk about a few next steps as well that you can do after this webinar has concluded. So if we were to perhaps look back maybe 6 years ago now, I think it was, there was a product that, as my colleague Nico likes to call it, became is the grandfather of Terraform Enterprise. It was a product called Atlas, and Atlas allowed customers to provision infrastructure using Terraform to various places such as AWS, GCP, Azure, VMware, and those different types of systems. And to be able to do that, customers needed to provide us with their customer keys, so credentials to actually provision into those various different platforms. So we had an internal requirement to obviously secure and protect those customer keys, because obviously if they were to be leaked, then people could provision into our customers' accounts. So we actually did some research in the market, trying to find an existing tool that would kind of meet the needs that we had. And when we did that research, the tools tended to broadly fit into sort of two different product sets. They had the privileged access management, or PAM solutions, which were typically very person-centric. They were designed to give a person access to a particular system. So if, for example, I needed access to a database server, I would log into the PAM system. I would get the database root credential, and I would be able to log into the database. Or perhaps I would take those credentials and I would configure an application to use them to be able to kind of talk to the database. But it was very kind of personal operator centric. And then we kind of had the opposite end of the scale. We had cryptographic hardware, things like hardware security modules, or HSMs, that were sort of designed to be interface with programmatically, but quite often it was complex to interact with those particular systems. They each have their own sort of specific commands and libraries, and developers sometimes find it difficult to integrate with those different types of systems. Plus, they tend to be quite expensive. They also tend to be quite difficult to scale as well. And this kind of left this sort of huge white space in the middle, where we needed a system that was able to both store but also sort of generate secrets, but also solve that challenge around the secret zero problem. So how can I automate access to secrets without perhaps pre-sharing a key or a username and password, and sort of hard coding that into a system or into an image, such that it can then log in and access a different platform. So basically what happened was there wasn't really a solution out there that kind of fit the requirements. So we built one. And interestingly, Vault was it was never really initially designed to be, to be released to the public. We had that kind of internal need for it. But obviously, as these things happen, you talk to customers, they say, how is it that you're kind of securing this data? We tell them about Vault, of how it works. And they say, that sounds fantastic. Can we have it, please? And the rest is history. And in 2015, Vault was actually released as an open source project. So as I mentioned, Vault really is a platform. We can't really talk about it as a tool now, because it's many different tools to many different people. And in some cases, it's multiple tools to multiple organizations, but really it kind of solves the challenges around, secrets management, being able to provide secrets to, to humans, to people, but also equally well to machines, to servers, and to containers. It also has capabilities around sort of data encryption and advanced data protection that we're going to spend our time talking about today. It's a very popular product. We know that it's processing over 2 trillion transactions that we know about. There's obviously probably many, many more that we don't know about. It has over 1 million downloads. I think if anyone saw HashiCorp last week, you'll have seen Mitchell talk about, Vault has, I think last year had about 16 million downloads. So it's actually just over 1 million downloads per month. And we've got many enterprise customers as well who are using the commercial solution. I think that number is actually probably closer to around about 400 by now. So in terms of what Vault does, this will be my sort of introduction to Vault, and then we'll talk more about those kind of advanced topics. But just so you understand what Vault is, so Vault is an API first product. So it has a HTTP API, a RESTful API. It also has a KMIP interface. We'll talk more about KMIP later. But ultimately, what this lends itself very nicely to is automation for people to develop applications that can easily consume the APIs that Vault provides. Now, don't think just because I say it's an API first product, it means that everyone needs to learn API commands. Everything ultimately will translate to an API command, but there is also a web user interface that uses API commands. There is also a command line interface that ultimately does use the API commands, but there's kind of multiple ways that people or systems can actually interact with Vault. The thing that I think that's made Vault very successful is that it's based on this concept of identity-based security. So what does that mean? So it used to be historically that, our identity was tied to things like IP addresses. If I have this particular IP address, then I'm allowed to access these other systems. And we probably know that IP addresses aren't a particularly good way to sort of leverage identity, particularly when we look forward to today and how people are deploying services. They're very ephemeral. IP addresses aren't static anymore. It's not a case of there's 100 IP addresses that never change. They are changing all of the time, often within minutes. So IP addresses not particularly good, but it was a means to identify workloads or people to a particular system. When we come to identifying ourselves as humans, we've probably actually had an easy time of this for, well, certainly the few decades that I've been working in IT. So, we've had systems like LDAP or Active Directory, whereas, as humans, we could authenticate and prove our identity to various different systems. Kind of fast forward to today, we obviously have some other approaches as well, things like OIDC, GitHub tokens, Okta as well, and kind of other IDPs that are available as well. But again, I think where Vault has been kind of successful is that it leverages identities for workloads as well. So, okay, as a human, I can type my username and password in, no problem. How can we get a machine to do that without kind of pre-sharing that information with a system? And the way that kind of Vault solves this is it leverages the identity that's actually baked into the platforms that we're actually using today. So AWS, Azure, GCP, Ali Cloud, Oracle Cloud, IBM Cloud, etc. They're all based on this principle that identity is a core part of their platforms. So we know when I spin up an EC2 instance, it is provided with identity from IAM inside of AWS, and that same identity can be used to authenticate to Vault. Kubernetes, Cloud Foundry, are also platforms that kind of leverage this concept of identity, which can then be used to identify a system automatically without any kind of operator interaction or installing and fingerprinting agents and kind of slowing the whole process down that way. These systems can automatically be created and identify themselves to Vault using that material. Now, simply because we've identified ourselves to Vault, once we're on the inside, doesn't mean we have access to everything. It's like we talk often about the security is, being that kind of castle and moat approach. Once we've crossed the drawbridge and we're inside, we have access to absolutely everything. We are trusted. But that isn't really the case. The networks that we're actually operating on today are either sort of low or zero trust. So just because I've identified myself to Vault, or just because my pods have spun up and they've identified themselves to Vault, what do they have access to? And Vault has a very strong concept of policy as well. So there's kind of different areas of policy that we have. Things like access control lists. Do I have access to read a particular secret or to perform a particular operation? It might just be I have read access to one single key. It might be broader access. Different people will have different levels of access, different servers, different application components will have different levels of access to different secret materials and operations inside of Vault as well. We also have something called Sentinel, which is our policy as code engine that allows you to define under what conditions can you access a secret. So you can access a secret if you've logged in with Active Directory from a known internal IP address range, you're using MFA, and it's between the hours of 9 and 5 a.m., for example. And we also have something called control groups, and I'm sure people are very familiar with GDPR and how that protects our data. But using something like control groups, that would mean that to be able to access a secret, I would need approvals from, I don't know, perhaps someone on my team, a manager, and someone from security. And if all of those people approve access to that secret, then I can get that secret material as well. Another absolutely important concept about Vault is its auditing capability. So this is a secrets management solution. We don't want to relinquish secrets without having that kind of full audit trace of who or what has accessed those secrets and what secrets they have actually accessed as well. So every request and response to Vault is actually sent to the audit devices as well. So you can have kind of traceability of who is doing what inside of Vault. And obviously those logs as well can be sent to some kind of SIEM system perhaps, or some kind of monitoring or aggregator system where you can also see what is actually happening inside of the Vault environment. So kind of once we've gone through all these steps, so we're using the API either directly or the web UI or the CLI. We've proved our identity either as a human or a machine, equally so. I think there's about 17, 18, 19, I forget, different sort of methods by which authentication can take place. Assuming we have a policy to access a secret, and then we're tracking all of the other things that we're doing, we get to the exciting bit, which are the secrets themselves. This is we need to go through all of those other layers. They're important, but what we're all here for is actually access to secrets. And there are broadly 3 different types of secrets inside of Vault. There are what we call static secrets, so sort of a key value store. It's a version key value store. So, I might want to store, sensitive information in their API keys, for example, and allow my applications to reference those secrets, either, the latest version or a particular version of a secret. But then we also have this concept of dynamic secrets, and dynamic secrets are, secret material that Vault is generating, maintaining, revoking, rotating. Things such as database credentials. If I want to have access to a database, I can request one from Vault, and it will, live just in time, will actually go and generate a username and password that's unique to me and return it to me. And not only is it unique, it will also be time bound as well. So it will be given a time to live, I don't know, 30 days, 7 days, 10 minutes. Really, it's up to you how you kind of configure that. So Vault is essentially leasing me that secret for a period of time. And once that time has expired, Vault will revoke that secret. So we're not giving out long-lived credentials that I'm going to put into, paste on Slack or something like that, and they're going to kind of live forever. They're going to be kind of time-bound. And there's lots of different dynamic secret engines, access to public clouds, PKI certificates, SSH certificates, and those different types of things. And then kind of the other use case, and this is where we're going to spend our time today, is crypto as a service or encryption as a service. So, the idea that we want to make sure we secure all of our data, but instead of trying to put the burden on cryptography on our application developers, because cryptography is very difficult to do. I speak to a lot of the Vault engineering team. They're very smart people, and it's a very difficult thing that they've managed to do. We want to be able to, use those capabilities we have inside of Vault to provide APIs to do things like encryption or decryption of data, sign or verify of our data as well, and also more sort of advanced topics as well, such as I think we're probably all very familiar with with encryption in general, but things like format preserving encryption is a request we've had many times from customers. We're going to spend some time actually talking about that today. And also things like key management as well. So I have a lot of systems that require an external key management service. I would like to use something like Vault using the KMIP protocol to be able to do those things as well. So let's talk a little bit about the sort of the data protection requirements that people will have. I think every organization that I speak to, large or small, has this requirement to secure sort of sensitive and valuable data. And there are reasons when we want to do it. It's just generally good practice to do so. But of course, failure to actually secure data has kind of serious consequences. So there are sort of, industrial requirements that we need to meet. There are laws and governances of the countries or continents that we're actually operating in. Things like GDPR. I've seen the we've all seen the kind of the numbers that you can actually be fined for failing to adequately protect customer data. There've been some customers in the headlines who are very, very familiar with them, because some of these fines have kind of run into the millions, many millions of dollars as well. And the kind of many regulations that mean that we need to actually protect these pieces of data. There's kind of different ways that we can actually protect all of this data as well. So quite often we'll actually use multiple of these, kind of have that security in depth approach. So things like encryption at rest, making sure that, data that is written to hard drives, for example, is encrypted. So, if the hard drive is stolen, or, as hard drives get replaced and they're disposed of, if they're not disposed of securely, I really like those industrial shredders that crush hard drives. They're kind of cool. But, if things like that don't happen, we've, again, all heard stories where someone has, perhaps purchased a hard drive, and then I've actually discovered that there is data on that hard drive as well. Encrypting data in transit, so as data flows through the network, making sure that it is encrypted and it's not passed around in kind of plain text. Tokenization is a popular approach as well. So, instead of actually storing, the sensitive data itself, we store a token, so a reference to that sensitive data. And we have something like a lookup table that allows us, if we need to, we can look up the token and retrieve the sensitive data. But, the sensitive data itself is never stored in an application, for example, just the token is. Format-preserving encryption, that's kind of long been theorized, but often we have times where we need to encrypt data, but we need to store it in the original format. There's lots of systems. There's a very popular 16-digit number that we're probably all very familiar with, that's been around for, oh gosh, many years before I was born, that we actually need to protect. So there's probably going to be many systems that are expecting 16-digit numbers. So, if people have seen ciphertext and what that looks like, it's quite often, it's a lot longer than 16 digits. It's made up of letters, numbers, sometimes kind of special characters as well. There are systems that just won't accept that format of data. So we kind of have that kind of problem where we need to encrypt the data, but keep the same format. I'll talk about how Vault kind of solves that in a little while. And data masking as well. We need a way to obfuscate data. So, quite often, perhaps we are loading data into a user interface. We've got some kind of customer relations management system where we need to kind of present data to an operator, but sensitive values we want to redact in some way or obfuscate in some way. Again, that 16-digit number is quite a popular one. Maybe we just want to present the last 4 digits of that 16-digit number, and obviously not the whole digit as well. And also another way that people are securing their data is using something like an HSM, a hardware security module, particularly for people who are subject to, FIPS 140-2 requirements. We'll use things like an HSM to make sure that CSPs, critical security parameters, are stored in a compliant manner. So let's just talk a little bit about some of those things, and then we'll talk about kind of how Vault solves them. So encryption at rest, I think probably all kind of familiar with this. We write data to a database. I took my colleague Sebastian's details. I took his social security number and his credit card number. He very kindly donated them for this webinar, and we're going to store those inside of a database. Now, we don't want to just write that data to the disk unencrypted for the reasons that we talked about before. We need to make sure that they are encrypted. Now, there are different challenges that we have in terms of protecting the encryption key. Like implementing, the cryptographic method is one thing, but protecting the encryption key is sometimes a harder challenge. It's probably the hardest challenge to do so. And there's many kind of bespoke ways of actually doing that. Tends to be point solutions. Perhaps we're storing it in an HSM. Maybe we're storing it in the file system itself. There's kind of different places that we might store that key, but essentially we need a way to protect that encryption key. Encryption in transit, again, works in a similar way. So, as an application, we write data to the application. So, as Sebastian is entering his details, I don't want to store things inside of the database inside of as plain text, because even if I'm using transparent data encryption and the data being written to disk is encrypted, well, my database is still subject to some kind of SQL attack. If someone was to say to a database, give me all of the data, and you were able to compromise it or get credentials from somewhere, it will return all of that data inside of plain text. So instead of writing to the database in plain text, we'll perhaps again transit our information through some kind of encryption system. Again, there's kind of different systems out there, key management solutions, HSMs, something that you've written yourself, so that data, when it actually gets sent to the database, is actually ciphertext as well, and we protect it in that fashion. So format preserving encryption, as we talked about, works in a kind of similar way to the use case that I just talked about before, encryption in transit. But there are often systems, traditional systems, legacy systems that have been written many years ago that are expecting a particular value. When we write a French social security number, we're expecting 15 digits. And if we're writing a credit card number, we're expecting 16 digits, for example. These are the types of things that a system will expect. And it's sometimes difficult or impossible to change schemas inside of other systems to allow you to write ciphertext. So we need some way to to preserve the format of our data once it has gone through an encryption process. And in the same way, masking, we can see here on the screen that the credit card is, instead of actually being written, has actually been masked first. And masking is a one-way operation. Once we've actually masked data, we can't actually retrieve it back. But it's useful for us to be able to see things like, the last 4 digits of a credit card number, for example. Let's talk about some of the challenges then that people actually have in terms of protecting their data. Why don't we do it? Why is it not something that we've all been doing for kind of many years? Now, one of the challenges that people talk to me about is the concerns and the increasing costs that actually has. So, as we bring on new systems, perhaps we need to use a bespoke key management system. So there's additional costs to actually do that. Perhaps I need to scale my HSMs, for example. I need to buy lots of HSMs, and as I said, they can be they're fantastically secure devices, but they can be very expensive, and the levels of performance perhaps might not meet the needs of your application as well. Also, what tends to happen is there are these, there's 10, 12, 15 different systems and different workflows that people actually need to use and leverage. So it becomes challenging for people to be able to, learn those workflows, learn the APIs, because it's going to be different for different projects, different teams, different technologies. And HSMs, as we keep talking about, often the access to those is quite restricted. And also just the risk is increased. Our data it's no longer secure inside of 4 walls with, badge access and kind of people stopping you getting in with one firewall in and out of the network. We've got kind of multiple ingress and egress points. Sometimes we don't even own the data centers. The cloud providers have done a fantastic job with their security, but it's not something we own ourselves. We kind of have that shared responsibility model. Not to mention that, switching a server from private to public in the cloud providers is essentially one API command. Whereas, historically, if I was to make a server go from the inside to the outside of the network, I'd have to recable it and plug things in. It would take time, and probably someone would notice that and stop me from doing it as well. So we need a solution that is, reduces the burden on things like, HSMs, multiple pieces of hardware, multiple costs. We want some kind of centralized solution that is, we manage it centrally. We have, standardized policies. We have a consistent way to be able to access it and use those cryptographic APIs that are actually available inside of the product. So the idea is, we want to increase productivity. We don't want people to learn 10 systems, learn one system, and then everyone will start using it. Create a system that people enjoy using, and people will start using it. And as I said, having something that is audited in one place is much better than trying to audit. I spoke to one customer; they have sort of 800 devices that they are actually trying to audit, and it becomes very challenging to manage all of those 800 devices. And as new devices are brought online, they don't actually know about them. So the security team are always kind of play catch up and chase these things. There were kind of different personas as well, as as we talk to different people, different people and different teams have different requirements. So we know CISOs will have, very kind of strict requirements in terms of compliance and auditing. Obviously, very, very risk adverse. They want control of the systems. Quite often when we talk to people using Vault, Vault is run by the security teams. They're brought in very kind of early into the process. This is something that is, very collaborative that they work on together. CTOs, of course, are very interested in productivity, making sure things are consistent and standard, because if we can do that, then everyone is going to start using them. And the fewer systems that we have to manage and the more value we get from systems will reduce costs as well. And of course, developers, there's no good building a system if none of your developers want to use it, because they will find another way of doing things if you don't present them with a system that is easy for them to use. Often it's quite enjoyable for them to use as well. And I think across all sort of three perspectives, automation is obviously going to be very important as well. We don't want systems that can't be automated, that have kind of very manual processes, because they're slow, and unfortunately they introduce a higher chance of mistakes as well. So now let's talk specifically about Vault and how that solves some of the challenges. So if we talk about Vault as an encryption as a service system, and I'm going to kind of go into all these in a little bit more detail, Vault offers something called the Transit Secret Engine. This is what provides encryption as a service. So we provide easy to use APIs that allow you to do those encrypt, decrypt, sign, verify operations. Vault will also protect those encryption keys. Remember, encryption keys are very, very important to protect. It's no good having a system that basically gives an application the encryption key, because then you need to trust your developers and hope that they secure that key in a secure manner. Vault has something called the Transform Secret Engine that provides format-preserving encryption as well. So we can encrypt our data in a way that it can't be easily reversed, but we keep the same format of it. And we're actually using a NIST-approved standard, AES FF3-1, if people are familiar with the term that allows it to do that. The Transform engine also provides that data masking as well. So we can create patterns that basically say, here's how we want to mask our data. When you retrieve this data and you send it to the Transform Secret Engine, based on the pattern you provide, it's going to mask that data and replace it with, well, a symbol that you choose. Maybe it's an asterisk or a hash or some kind of system like that. And Vault also supports KMIP as well. So KMIP is the Key Management Interoperability Protocol. So this is the sort of the standard that systems like VMware and NetApp actually use. That's the protocol they use to talk to external key providers. So the Transit Secret Engine, just take a look at what that kind of looks like and what that workflow would look like. So imagine that I have an application that wants to encrypt this data. We'll use again this social security number. When I actually want to encrypt it, I would send that data to Vault using an API that says encrypt with a particular encryption key. So I can generate as many different encryption keys as I want to. Vault will manage those encryption keys. I can, rotate those encryption keys. I can decommission the keys. I can do things like set minimum versions for encryption and decryption operations. That is all something that can be managed inside of Vault. But to actually consume it as an application developer, I say, here is the data. I want to do an API encrypt with the SSN encryption key, please. Vault will actually encrypt it and then return the ciphertext back. We can see this sort of ciphertext on the screen. We've truncated it slightly, but it basically will have something like, Vault V1. So V1 is actually the version of the key. So as I mentioned, Vault manages different versions of the key. We can actually rotate those on a frequent basis. So when we actually store the data, it's the encrypted data that we store. So even if someone was to compromise my database directly and pull information out of it, all they would actually be getting is ciphertext. Unsurprisingly, if you want to decrypt the data, the reverse is true. We send the ciphertext to the API that allows us to decrypt the data. We say which key we want to decrypt the data. Vault will decrypt that data and return it to the application. Now, one thing I think is worth pointing out, actually with all of the functions that I'm going to talk about, is that inside of Vault, the function to encrypt and decrypt are obviously separate capabilities inside of Vault. And because they're separate capabilities, we can have separate policies. So for example, I might have a front-end system where people are entering data. That front-end system has a policy, so permission to allow it to encrypt data, but it does not have a policy that allows it to decrypt the data because it's a front-end system. Maybe it's a higher risk, a point of compromise. We don't want someone getting onto our front-end system and being able to decrypt the data. So don't give it a policy that does that. Whereas I might have a sort of a back-end system that that isn't sort of publicly facing, that does have a policy that allows it to kind of decrypt the data. And this is, and it can even be down to the particular key, right? So I have a policy that allows me to encrypt with the SSN key. I'm not allowed to do any encrypt operations or decrypt operations with any other key, for example. The transform secret engine, unsurprisingly, works in the same way. And this is another important thing to point out about Vault is, the workflows for all the different technologies that I'm going to talk about and the technologies that I'm not talking about today are extremely consistent. So the idea is that, once you can do sort of one type of operation inside of Vault, it's the same pattern to, retrieve cloud credentials or database keys, or I need access to an AWS S3 bucket. It's the same pattern that we're actually following. So in this case, we send the number in 15 digits to Vault. It uses AES FF3-1 to actually encrypt that data. So it is still using a form of AES, so it can't be reversible. And then it will actually send the data back, and it will be in the same format. And then I can store that encrypted data. So that's 66987234222 that we see on the left-hand side of the screen is actually an encrypted value. Now my database is probably expecting a number in that particular format. So my database is very happy. I've not needed to modify my data, my database at all. Those things can be very difficult, particularly for long living systems or systems that you just, can't make those kind of detrimental changes to. Decode works exactly the same way. We send the encoded data. Vault will decrypt. Again, it never relinquishes the key. For both transform and transit, we don't relinquish the key. We protect that inside of Vault, and then we return the plain text back to the application. Data masking works in an exact way as you'd expect it to. So we would define a pattern. So we say to Vault, okay, I'm going to give you a 16-digit number. I want you to mask the first 4 digits or the first 12 digits or whatever it is. You can choose. You could do the first, the third, the fifth. Really, the combination is kind of up to you. And it doesn't just need to be digits. It obviously can be sort of alphanumeric strings as well. But essentially, when we send this data to Vault, it will do that one-way encoding. So it will basically it will mask out the characters that match the pattern and then return that data back. And because we're doing masking here, we're essentially losing data. There is no way to actually take a hash and actually restore it back to the original value. KMIP, as I mentioned, is that sort of key management interoperability protocol. Easier to say KMIP than the full name. And there are systems such as VMware, NetApp, MySQL, MongoDB, for example, that can leverage external key providers to basically manage and protect the encryption keys that those systems use. So, for example, VMware, I want to do VM encryption. I need an external system to actually manage those keys for me. What's really nice about the VMware solution is it's not dependent on what particular SANs you're using. If you're using NetApp as well to kind of back VMware, you can encrypt it at both levels, but it's not dependent on the storage that you use. We can interface with Vault using KMIP. Another great thing about Vault is it's not limited to a single KMIP server. So Vault has this concept of namespaces. So you might have multiple tenants that are using this centralized Vault solution, each with their own namespace, each with their own KMIP, each with their own permissions, each with their own policies, and these different types of things for different use cases or different applications as well. And KMIP is an open standard, so there are many different vendors that actually support KMIP for their solutions. Not only that, but Vault can optionally integrate with an HSM, and many of our customers in the financial sector, in fact, I would say the majority of them actually do. And that HSM integration provides a kind of a few different capabilities. One is it helps protect Vault's encryption key itself. So Vault, has storage, and it will actually encrypt data when it's sent to storage. Vault uses AES 256 bit, uses Galois counter mode, if anyone's interested in the details of that, to actually encrypt all of its data, so it's never persisted in plain text. And if it did, I would jump back to the start of this presentation and go over that again to myself. But it encrypts all of its data, and then we still have this challenge of we need to protect this encryption key. Well, we actually leverage the capabilities inside of an HSM to help us protect that encryption key for Vault as part of what we call the unsealing process. So you'll perhaps see references to the auto unseal process and how we can leverage HSMs to do that. We can also use HSMs for something called seal wrap as well. So for critical security parameters that we have, perhaps we need to store those in a manner that is compliant with FIPS 140-2, we can optionally enable that on the secret engines inside of Vault, such that that data will be encrypted not only by Vault will always encrypt its data, but it can additionally be encrypted by the capabilities inside of an HSM as well. And the third use case is for entropy augmentation. So people are no doubt familiar with the generation of random numbers is a very, very important factor in strong cryptography. And we want to source entropy from a hardware source, for example. HSMs often have some kind of radioactive material in them, for example. Based on the decay of that, we can generate kind of true entropy. It's very interesting. Vault can use the HSMs to source that entropy. So the two main use cases for the KMIP integration is for that full disk encryption. So things like NetApp, I want to make sure that all of my data, when it's actually inside of my SAN, is going to be encrypted. Then we can leverage Vault's KMIP capability to do that. Same with virtual machines as well. My VMware estate, I want to make sure that all of my data is going to be encrypted inside of my SAN, regardless of what type of SAN that I'm using. Or you can actually also vSAN also supports KMIP as well to do encryption. And then things like TDE, so transparent data encryption as well. So, when my database is persisting data to disk, I want to make sure that it is going to be encrypted. So things like, MySQL and MongoDB support KMIP for those type of operations as well. This is kind of a nice diagram. We kind of see at the top, we have all of these different key management systems to support all the various different kind of infrastructure and applications that we have. But using something like KMIP, which is a standard that these systems actually support, we can consolidate all of those systems to a single central audited capability as well. Okay, this is the exciting bit. We're going to get to the demo now. It's a very simple demo, just so I can show you some of the data protection capabilities inside of Vault. What I'm going to do first is I'm going to show you how the demo looks basically without Vault. So it's a simple Python web application that is reading and writing data to a MySQL database backend. And we're going to kind of see that that data isn't encrypted in any way. And then we're going to introduce Vault, and then you'll be able to see some of the, the capabilities such as transit and transform that allow us to protect our data. So if I jump over to here, let this load. There we go. So I'm going to run this application. It's not actually running at the moment. If I hit refresh, it's not actually running there. So this is a very, very simple demo. So let's just wake this up. There we go. So I'm going to be using Docker for this. Some of the things that I'm going to do as part of this, I certainly wouldn't recommend, but for a demo, it's absolutely fine. Don't worry too much about some of the commands that I'm running. I will actually point out the important details. Don't try and read everything that you see at in the scripts that I'm actually running, because most of it you won't actually need. So I do need to use MySQL. What's interesting here is one of those bad practices that I said you should never do is I've actually set my root password to root, which is a terrible practice, but for demo purposes, you'll see that it actually makes my life a little bit easier. Making my life a bit easier is not a good security practice though, so don't follow me. Also, I'm going to configure my application. So if I look at my application's configuration, I will see that it's using a database, the MySQL database. The actual database itself is called MyApp. But again, bad practice here. I've actually hard-coded my username and password. Not only have I hard-coded it, which is a bad practice, I'm also hard-coded the root password, which is a terrible idea. And as you can see here, I've not enabled the Vault capabilities inside of this application right now. And then the last thing I'm going to do is I'm going to run my application so you can actually see what it looks like. And this is basically running, as I said, without Vault in place. So let's take a look. Hopefully our application is running. I'll give it a second. Oh, there we go. There, just took a second, I think. There we go. Okay, so if we look at our application, a very simple application. We're not doing this at the moment. This is ultimately what I want to get to. I want to be able to provide, some kind of input, send it to Vault, and it will send me ciphertext back, which I'm going to store inside of my database. And similarly, I want to provide some input to Vault. I want it to do format-preserving encryption and return that data back to me in this sort of format here. If I actually look at what the data looks like inside of my database at the moment, so this is my application. I've got a number of people in here, some sensitive information such as date of birth, social security number, credit card numbers, perhaps their address as well. I also have this database view, this is a raw view of the database. So the records themselves in the database view look exactly the same at the moment because the data is all in plain text inside of the database. Now, if I was to add a record real quick, so I'm going to put myself in here, Russ Parslow. I was born on the 1st of May, 1990. Not that anyone believes that. I'm going to put my social security number in here and my credit card number as well. I was very lucky when they were handing out credit card numbers. I got this really easy to remember one. So please, I hope nobody on the call steals that. Okay, and I'm going to submit that. And you can see I've just added a record down here to the bottom. And if I look at the database view, yeah, it's all in plain text. This is terrible. I hope nobody steals this information from my database because otherwise I'll be in big trouble. So let's see how we could have done that a lot better. So I'm just going to stop the application for a second. And then I'm going to start Vault running. So if we look, I'm just using a simple command to actually start Vault. What's really nice about Vault is we have something called the development mode. So I can actually run this and do some testing against it. Again, this is not how I would actually deploy Vault into production, but just for the demo purposes, it should be quite easy to do. Okay, and that is Vault running. I need to apply a license to this because I'm using some of the enterprise capabilities, which I have now done so. Okay, so now I'm going to set up Vault's database secret engine. So I talked a little bit about the secret engines that Vault actually has. The database one basically allows Vault to generate credentials for databases basically on the fly. So the way that I do that, and again, don't worry too much about all of these details and trying to follow this, but you just want to show you that some of the patterns you'll see as I go through this are the same. So first of all, I enable the database secret engine. Then I provide some configuration to it, which basically says, here is where the database lives. Here is how you connect to the database. You need a username and password to do so. So that is not good practice to use root and root, but there's a nice feature of Vault that we have, which is this one on line 26 here. What this basically does is it says to Vault, okay, now that you can talk to the database, rotate the root password to something that only Vault knows. So once I run this command, I won't know what this is. Vault will know what it is, and Vault will manage this, but I will no longer know what it is. So it's a really nice way to say, here are some credentials, Vault, but now you manage them so that no one else knows what they are. So I can't just come and log into the database as root and root. We configure a couple of roles here. This is basically saying to Vault, when you generate a user, this is kind of the creation statement I want you to use, and things like the time to live as well. So, I want this to run for this. Sorry, I want this credential to be valid for 3 minutes, and after 3 minutes, Vault is going to delete that user from the database. So let's run that now. So that all goes through, and if you can see it, if you can't, trust me, this is basically a live credential. This has actually been created in the database now. And obviously I could run this command multiple times and Vault will create kind of multiple users inside of the database if I wanted to. Cool. So let's also set up our transit secret engine. So if I do this one, so transit allows us to do things like AES encryption. So we're actually, these keys that I'm creating here, so you can see create these keys, they never actually get returned to me. Vault says I've created them, but it doesn't give me those keys because I don't want to have to protect those keys. I want Vault to do it for me. Again, enabling, same way we enabled the other secret engine. And then just to test that it's working, we encrypted some data. So I sent my secret data to both the customer key and the archive key, and I can see that Vault has actually returned that ciphertext back. So the transit engine has actually been set up. So that's good. The next thing I want to do is I want to set up the transform secret engine. Now the transform secret engine is our format preserving encryption secret engine. So again, I enable it, same commands. Again, don't worry too much about the exact wording, but just notice that it probably looks very familiar because they all look very similar. And what I'm going to do is I'm going to set up a role that allows me to perform this transformation, which I call SSN, social security number. So that transformation is using format-preserving encryption. I'm using a built-in template. Now I can provide my own template and I can provide my own alphabet to use inside of that template if I want to do so. The other thing that I'm going to do just for simplicity is I'm going to use what's called a tweak source as internal. Now a tweak source is, if people are familiar with other methods of encryption, they're familiar with contexts or salts, those different types of things. A tweak source is the same thing, but for format preserving encryption. Now I'm going to have Vault manage this, but I could have Vault generate one that I need to store myself, or I could actually provide one to Vault. I can say, I'm going to provide you with the tweak sources. So that's something you can optionally do as well. So I basically ran this command and we see here that I said to Vault, I want you to encrypt the version 111.222.3333 And it's done so here, but it's actually retained the format. So 3 digits, 2 digits, 4 digits was the format I entered. And that is also the format that Vault has actually returned to me as well. I'm going to set up masking as well. So if I look at this, again, very, very similar to what we've seen multiple times already. In this case, I'm going to say the transformation I'm going to use is for credit card numbers. And I want you to basically use this hash symbol to actually mask my data. And this is the pattern I want you to match. So if people aren't familiar with this, this is regex. You know, you can write your own regex to say this data input should actually match this particular pattern. And this is what we've done down here. You know, I passed in this credit card value here, and I can see that it's actually encoded it and returned the last 4 digits, which is actually what I wanted to do. This is obviously only one way, so I can't basically take that number and then get back to the original number, because that's how masking works. Also, this is kind of nice, a little bit of an unexpected part of the demo, but remember that database credential I set up in step 8? And I showed you that database credential that was valid for 3 minutes. Vault's just revoked it. That 3 minutes has expired since I set that up, and Vault has actually removed that credential from the database, so that can no longer be used. So if anyone was fast enough to take a screenshot and try to copy and paste and log into my database, I'm sorry, that won't work anymore. Okay, so the next thing I want to do is update my application configuration. So let's do that now. Let me show you what the configuration looks like now. So my configuration is using, again, I know where I tell my application where the database is, but I no longer hard code my root username and password into this application, because my application is going to get dynamic database credentials from Vault that are only valid for sort of 3 minutes or so. And then obviously after 3 minutes, it can request new ones if necessary, but it's going to keep those database credentials rotating on a frequent basis. I've now enabled the Vault integration, and I've passed some additional information to the application to tell it where inside of Vault to find particular sources of data. And then the last thing I need to do is restart my application, but this time it's going to be using Vault. So give that a few seconds to run through, and hopefully if we go to here, okay, application looks to be running. Look at our records, nothing has changed there. If you look at our data, nothing has actually changed there either. So I haven't actually gone back and re-encrypted the data inside of my database. That'd probably be a good thing to do, but I've left it as it was before in plain text, just so we can kind of very distinctly see the difference between the data. So I'm going to add a record again now. I'm going to say Russ, and this time I am using Vault, so I'm just going to do that. I'm going to put everything else in the same. Oops, if I could spell my own name, I'd be useful. I was still born in 1990, I wish. And I'm going to put my social security number in and the credit card number again. I'm going to put all the same data in so we can actually see how it compares to how this was before. And I am in London. So I'm going to submit this. Fantastic. Now, if I look at my application data, it looks fairly similar to what it looked like before. Obviously, I changed my first name so we could actually see the difference. All looks pretty good. I can see my date of birth. I can see my social security number. One slight difference: when I input my credit card details, instead of storing the 16-digit number, I actually stored it masked, so I can actually see that this has actually been masked. And I'm based in London, so everything looks the same from the application point of view. But let's actually look what's inside the database itself and see how that differs. So this table now looks a lot different because the data is trying to squeeze it in. So if I scroll down to the bottom, you can see straight away that there's a big difference between how this data is actually stored inside of the database. For example, my date of birth is now encrypted. This is ciphertext. This is using the transit secret engine. That's all kind of a bit of a mess now, which is good. My data is protected, it's encrypted. Obviously, from when I'm looking at my application view, it's sending this encrypted data to Vault to decrypt. So when I'm presenting this as the application itself as the records view, I can see this decrypted, but the actual raw data itself is encrypted inside of my database. Same thing with my social security number. It's used the same format. So we still have this 3-digit, 2-digit, 4-digit format, but it's used the format-preserving encryption. So this actually decrypted is 123, 12, 1234, but it's actually encrypted inside of the database. The credit card we talked about, I'm actually storing the credit card inside of the database as this encrypted, as this masked value here. And also my address, because wouldn't it be terrible if I gave you my date of birth, my credit card number, and my address? Goodness knows what people could do with that data. That's also been encrypted in here. And obviously we can choose which pieces of data we actually want to encrypt. as we would perhaps rotate this encryption key and add new data, basically we'll see this go from V1 to V2. So I would be able to rotate the encryption key without ever exposing that encryption key outside of Vault. Okay, so that was the demo. It's just kind of real quick look at some of the different methods that we have inside of Vault to actually protect your data. A really quick case study. I think probably everyone is familiar with this story. It kind of did hit the headlines a little while ago, where customer data was exfiltrated from an organization's database and posted online. And once they kind of tracked down where the problem was, it was in a new system that had been put in place that had some kind of vulnerability that allowed people to basically move laterally across the networks. I think they were sat in a car park, got into a store Wi-Fi across a VPN and across these kind of various different systems, and they were able to exfiltrate that data from a database. Really kind of proving that the model of, if you're inside the network, you can trusted, you should be able to access things, is a very, very bad practice. Just because someone is inside your network, zero trust, trust no one, authenticate and authorize everything. Now, intrusions do unfortunately happen. It probably happens more than some of us realize. So using things like the advanced data protection capabilities of Vault, such as transit, transform, KMIP, for example, to actually protect the data in transit, at rest, provide that key management solution, is obviously going to be very important. I mean, it wouldn't be great if someone was to get into our systems and steal encrypted data, but I will sleep a lot better knowing that if someone does get my data, it's going to be encrypted, and it's going to take them possibly till the heat death of the universe to actually be able to decrypt it. Helps me sleep a little bit better at night. So again, and the idea is having this central solution that has easy to consume APIs that, basically you can learn one system and then use it for all of your applications, means that the level of productivity will increase inside of the organization, while also reducing the risk. We have this central solution, it's being governed by rules and policies that have been set and are managed typically by sort of ITsec teams. And we know that, the data when we're storing it is going to be encrypted. So let's talk about some next steps, and then we'll have a little bit of time for some questions. So I take a look at the advanced data protection page we have on the Vault website. It goes into a little bit more detail about some of the capabilities and some of the functionality. For those people who like to be hands-on, or have colleagues and team members who like to be hands-on as well, I certainly take a look at the Learn platform. So a lot of the things that you saw me today, I was really quick, and I kind of just said, these commands, trust me, they work, and they did. But we didn't really go into those in any particular depth about what it is and what they do. The Learn platform literally has all of these details actually step by step for people to follow, has explanations of what each step does. So if you know people who want to kind of get hands-on with some of these capabilities, that would be the place that I would recommend you go and take a look. And as I said, this has kind of been a fairly sort of advanced talk in some ways. We didn't really go into a lot of the details around sort of how Vault works and how some of our customers are using it as well. So I would give a real big shout out to the HashiCorp, which took place last week. All of the recordings are available to stream on demand. So if unfortunately, as I didn't get a chance to catch all of the talks, I will certainly be going back and watching a lot of the talks that came from our own internal teams, but also our customers as well. Then go and take a look at the HashiCorp website. We also have the recordings from the one we held in the digital event we had in the EU back at the start of the year. All of those videos are there and available for you to watch. And with that, I will hand back to Connor.
Amazing. Thanks a lot, Russ. So just kicking off with a few questions, starting with one in relation to the demo specifically. Were you running all of that locally?
I was running all of this locally, yes. So one of the things that, as I said, I like about Vault, without getting into sort of the whole infrastructure and how it is actually deployed, I wasn't running this locally in a production-like manner. I'll just get that out of the way first. I was using it for demo purposes. But one of the things I really love about Vault is it doesn't have this high barrier to entry for you to try things out. So, with some systems, it's like, oh, I'd like to try that out. Well, first of all, I need to spend a couple of weeks learning how to deploy it and all these different types of things. You can literally go from, I'm really curious about Vault. You can download it and have it running on your local machine in however long it takes you to download the binary, pretty much, plus about 10 seconds to run a command to actually to run that locally. That is something that is available on the Learn platform. It tells you how to actually do that. But I mean, literally, 5 minutes after this webinar finishes, you could actually be trying some of this stuff out yourself.
Amazing. Question 2, is there a limit to the number of encrypt, decrypt operations Vault can support, and how high can it scale?
Oh, great question. So it's very difficult for me to say how high it can scale because I don't know of the theoretical upper limit. And what I mean by that is, so things like the transit secret engine and the transform secret engine were written in such a way to make it horizontally scalable in the commercial solution. So we have something called performance standbys. And again, without getting too much into the details around sort of how Vault works, it basically allows you, as required, to add additional Vault nodes that can service those kind of encrypt, decrypt, encode, decode types of operations. So, if I was to run something like this on my lowly little MacBook, I might get sort of a few thousand transactions per second. But we've had customers who've kind of run into the the tens of thousands and some even kind of hundreds of thousands of transactions per second. So there probably is some theoretical upper limit. But I have never heard of a customer, even the largest customers, who've actually hit any kind of those limits. So it does scale exceptionally well.
Great. And another great question here as well. How is Vault deployed? Is it available as a managed service?
Another good question. So there are broadly two ways we can deploy Vault. So again, I'm going to keep pointing at the Learn platform because it's a fantastic resource. But if you look at the Learn platform, you'll actually see there are reference architectures for Vault and how that is deployed. It's deployed in a highly available manner. So it's not like one server and cross your fingers and hope that doesn't fail. So you actually would deploy Vault as a number of nodes that would form a cluster. So it has high availability within that cluster. There are, again, additional capabilities that we have in Vault Enterprise, such as replication between clusters. Perhaps you might have multiple clusters in different data centers. You want to replicate kind of data between them. I'd certainly take a look at the reference architecture for how that is actually deployed. And in terms of a managed service, there's another good link on this slide that I recommend you take a look at, which is the HashiCorp Digital, because one of the things that we talked about there is the HashiCorp Cloud platform that will allow you to basically have Vault running as a managed service. So, if you want to run Vault, but you don't want to run it yourself, you can, go to HCP, click a button, and we'll deploy it inside of your VPC. We'll manage it, take care of all the backups, the upgrades, and all of those different capabilities. So take a look at it now. We actually have a sign up for a public beta as well. So if people are really interested in getting involved in that, take a look at that.
Great. And the last question for you is, where does Vault store its data and how is it protected?
Yeah, good. So Vault has a number of storage backends that it will actually use. There are two that I recommend to you, very strongly recommend to you, not only because we actually use them, we've actually written them and supported them ourselves, but that is something called Consul. So Consul is another one of our products that provides actually a number of capabilities for service mesh and service discovery and those different types of capabilities, but it also provides durable storage as in the form of a KV store. So Vault can actually store its data inside of Consul, but also, and this gets a little bit inception, Vault has something called integrated storage. So the Vault binary itself, by the way, Vault is just one single binary. It's not like hundreds of files. It's literally one file, download it, and that's everything. That binary itself can actually provide storage as well for Vault to be able to store its data. There are other storage solutions that are available. They don't have the same, typically have the same capabilities as integrated storage in Consul. So I would strongly recommend you take a look at those. And in terms of the data that goes into the storage backends, it's always going to be AES encrypted. So Vault, never persists anything in plain text for the reasons that we talked about during this presentation. So it encrypts all of its data using AES 256-bit GCM before it is actually sent to storage, or what we tend to say is when it leaves Vault's cryptographic barrier. So basically it will always be encrypted, and we protect the encryption key that is used, as we mentioned, with things like with HSMs as well. We can also use things called Shamir. So if people are familiar with Shamir secret sharing, we can also give part of a master key to a number of trusted key holders to basically reconstruct it, or we can use something like an HSM or a KMS to do that.
Great. Well, thanks a lot, Russ. incredible session. So with that, as Russ mentioned a number of times, actually, if you do fancy learning more about HashiCorp Vault, then we really encourage you to check out our online learning platform where you can try some of these great features for yourself. And as you can see on the screen there, you can find it at learn.hashicorp.com/vault. And lastly, just a reminder, this webinar was recorded and we'll make that recording available on our website after processing. I'll send you a link via email as well, and it should be ready later this week. All right, so I hope everyone enjoyed today's session, and thanks so much for joining us. Thanks, everyone. Goodbye.
Thanks, everyone. Bye-bye.